Hello, this is the luckiest maths teacher in the world. Thank you so much for watching as we go through the basics of probability. Now, why do we have probability? Well, we're always interested in how likely events are to occur. We talk about that even outside maths. So probability in maths formalizes this idea, and it allows us to compare the likelihood of events. So for example, you might be thinking to yourself, is it more likely that Queensland would win the State of Origin this year, or that the Broncos would, say, win the NRL Premiership? Now, you probably find quite a number of views on that. It's a hard thing to say, one is more or is less likely. But with probability, what we do is to each of those events, so first event, Queensland winning Origin, second event, Brisbane winning the NRL Premiership, to each of those events we give a number. And numbers allow us to compare the likelihood very easily because it's very clear cut whether one number is larger than another number. And so events with a larger number assigned to them have a higher probability. So you probably know this already, I'm just explaining it in a different way. So let's look first at the number line between 0 and 1. So why do we want to do that? Why do we want to look at the number line between 0 and 1? Well, when we're assigning probabilities, we're assigning numbers to indicate the likelihood of an event, we always use numbers between 0 and 1. And that's because probability is basically a proportion. And hopefully you remember that 1 is the same as 100%. They are the same number. And you can't have something happening more than 100% of the time, now can you? So a rule for probability is written like this. Probably looks a bit complicated to you, but don't worry, I'll explain it. So firstly, this P bracket E thing here, that means the probability of an event. Okay, so an event is just something that may or may not happen. For example, rolling a die, getting a 2, that's an event. So the way you read this here is the probability of an event is between 0 and 1. So when we're talking about probability, we're talking about events, its probability will lie somewhere on this number line between 0 and 1. So obviously halfway between 0 and 1 is the number half or 0.5. It doesn't matter whether we use fractions or decimals. So as I said before, the higher the number, the more likely an event is to occur. So at 100%, we say that an event with this probability is certain. So if an event has probability 1, it is certain. So for an example of a certain event, I toss a coin and I get either a heads or tails. That's certain. I'm definitely going to get a heads or a tails. So that's going to have probability 1. So things that have a probability, events that have a probability close to 1, we say that they're likely, and they're becoming more and more likely as we go along the number line. Of course, half, you might also call it 50-50, so that's an even chance. So if an event has a probability of half, it's just as likely to occur as it is to not occur. And if an event has a lower probability than this, then we say it's unlikely. So as we're going down this number line, events are becoming more and more unlikely. So they're more likely to not occur. And of course, 0, if an event has probability 0, it's impossible. There is no way it can occur. So an example of an impossible event would be, let's say I multiply together 2 even numbers and I get an odd answer. That's impossible. You can't multiply 2 even numbers together and get an odd number. Okay, so we know what probability is. We know that all probabilities have to be between 0 and 1. We know how to decide whether an event's impossible, unlikely, even chance, or whatever. Now we've got to look at actually assigning numbers to events. So pause and copy this down if you need. Okay, so the basic formula behind probability here is the probability of an event, remember that's what this means, is the number of ways the event can occur divided by the total number of outcomes. So this is a proportion, it's a fraction, it's a decimal, it's obviously going to be less than 1. So when we're talking about this formula, it's helpful to know what's in the sample space. So if you recall, the sample space is just the set of all possible outcomes. So it's just a group of events that can actually happen. So for example, if I roll a die, the sample space, and we usually use these squiggly brackets for it, is just 1, 2, 3, 4, 5, 6. So this is just a normal die that I'm talking about. So I could get a 1, I could get a 2, I could get a 3, and so on all the way up to 6. So that is the sample space, and that tells us the total number of outcomes. I know you already knew this. If I roll a die, there are 6 outcomes. So if I write this means probability of a 2 occurring. If I roll a die, there is 1, 2, so there's one way it can occur, and there are 6 outcomes in total. So the probability of getting a 2 is 1 over 6. Or if you like as a decimal, that's 0.16 recurring, or 16.67%. So the probability that I get, say, a 2 or 3. So there's 2 ways that can occur. I could get a 2 or I could get a 3. So it's 2 out of 6, or 1/3. Now make sure you understand that this formula can only be used if all outcomes are equally likely. So for example, let's say I wanted to find, I'll do this up here now, let's say I wanted to find the probability I get a multiple of 3 when I roll this normal die. Now, you can't say, okay, there are 2 outcomes. I can get a multiple of 3 or not get a multiple of 3, therefore it's a half. That doesn't work because they're not equally likely. It's actually more likely that you won't get a multiple of 3. So we're going to do this the same way. We're going to look at our sample space, find out how many multiples of 3 there are, and there are 2. There are 2 ways I can get a multiple of 3. I can get a 3 or a 6. So again, the probability would be 2 over 6, or 1/3, if you like, 0.3 recurring, or 33.3 recurring percent. So I should tell you at this point that all of this stuff we're doing at the moment is theoretical probability. So this is basically what should happen. So when I say the probability that I get a multiple of 3 is 2 out of 6, or 1/3, that means that 2/6 or 1/3 of the time I expect that I'll get a multiple of 3. You probably know very well that the probability of getting a heads when you toss a coin is a half. So that's theoretical. In theory, we should get head half the times. However many times we do it, divide it by 2, that's how many heads we should get. So from this, we get the idea of expectation that I'll go through now. So please, again, pause and copy down if you need. So the number of times that you expect something to occur is just the probability that it occurs at each trial times the number of trials. So this is a pretty commonsensical idea. So let's look at these examples. So let's say, firstly, that I toss a coin 400 times. How many times would I expect to get a head? So we can use the formula above. So the number of expected successes, in this case a success is getting a head, the number of heads I expect would just be the probability that I get a head each time I toss the coin, a half, times the number of trials. And a half times 400 is just 200. I'd expect 200 heads, 200 tails. So if I roll a die 120 times, how many times would I expect to roll a multiple of 3? So I just showed you on the previous slide, in a previous example, that the probability of rolling a multiple of 3 each time is 1 over 3, or 2 over 6. So if I do that 120 times, I'd expect that 1/3 of the time I would get a multiple of 3. So I just times 1/3 by 120, the number of trials, and I get 40. Easy as. So there's just one more thing we have to do, which is experimental probability. So I said before that theoretical probability is what should happen. Experimental probability is based on what actually happens. So in a previous example there, we were talking about the expected number of heads. So I found out that if I toss a coin 400 times, I would expect 200 heads. But of course, that might not actually happen. If I toss a coin 400 times, I probably won't get exactly 200 heads. I might get close, but I won't get exact. So experimental probability would be if I actually do the experiment, the proportion of times something happens. It's also known as, and it's pretty much the same thing, as relative frequency. And so relative frequency or experimental probability doesn't have to equal theoretical probability. So the formula is just the number of times that an event occurred over the total number of total number of trials. So let's say, for example, that I tossed my coin 400 times, and let's say I got 180 heads. So the theoretical probability of getting heads is still a half. I still expect that I will get heads half of the time. I still have a theoretical probability of a half because there are two outcomes and one of them is heads. But the experimental probability of getting heads is the number of times I got heads divided by the total number of trials. So in this case, it would be 0.45 or 9 over 20. So the theoretical probability is still a half, but the experimental probability is 0.45. So I would expect, if I toss a coin heaps of times, that I get heads half the time, but that may not happen. So experimental probability is different. So make sure you understand the difference between them. All right, hope you've enjoyed the video. This has been the luckiest maths teacher in the world. Have a great day.